Hello friends, welcome to yet another interesting discussion under projectile motions. So this is the second part where we're just going to look at the maximum height of a projectile. So remember we said that projectile motions are in two dimensions, while we have the x-axis and the y-axis both being independent linear motions. So now I'm going to draw this trajectory, which is the path taken by a projectile. Now, one that you need to know is that this path taken by a projectile, which is known as the trajectory, is shaped like a parabola. So I'm going to do that. Now, from this point, this arrow represents the speed at which the particle is moving at. And what will happen is, because of the force of gravity acted upon it, it will divert, hence making something like a parabola, which is its trajectory in this case. Now this point is the highest point reached by the particle. So meaning that from this point to the horizontal, which is the x-axis, this length or this height is what we call as the maximum height. So in this discussion, we're going to study the maximum height and see what is involved and how we can calculate it. So I'm going to derive a formula for you that you can simply use when you're looking at maximum height. So I'll represent this as h, then subscript of max to mean maximum height. So this is the height from there, the horizontal to the highest point reached, which is vertically. Okay, now that is our highest point reached there. So the highest point reached to the horizontal down there on the x-axis, we get the maximum height. All right, now before we look at this maximum height, let's consider the velocity components that we looked at in our previous video. So if you've not yet watched that video, please do so, as it will be the reference point of this video. So let u be the speed at which the particle is moving at, and theta be the angle of projection. Okay, so we'll look at the x components. So for the x component, look at the initial velocity component and the final velocity component. But if you remember from what we did, both the initial and the final are the same because it is constant. So this was the formula, which is u cos theta, which we did show using trig, and also for the final, the mirror above the y. So for the final, it's also the same because initial and final is just the same for the x component. So u cos theta. Now coming to the y components. For the y components, initial and final are not the same. Okay, so for the y components, the initial speed, which is given as this, is equals to u sine theta. U sine theta, like that. Then the final is given as u sine theta minus gt. So we did derive this from our previous discussion, which is u sine theta gt. Okay, now there's something that we need to note, because here our main aim is looking at maximum height. Now we need to note something. So we have speed, velocity in the y and the x component. So one that you need to note is that the vertical component of velocity, we're looking at the y component, the vertical component of velocity at the highest point reached simply gives you a 0. So when you're looking at the projectile motion, just keep in mind that the vertical component of velocity at the highest point reached or at maximum height gives you a 0. Okay, so at any other point it might have a value, but particularly looking at the highest point reached for a particle that is undergoing that is in this same trajectory, this particle, which is a projectile, gives you a 0. So this implies that v subscript of y is equals to 0. Now if you remember, this final vertical component of velocity, the formula is the one that we've just expressed above here, that we also had to show you in the previous video. So this is equal to u sine theta minus gt. Now let us find its value at maximum height. So since it is 0, we're going to equate what is on the right hand side to be equal to 0. So it will be u sine theta minus gt. On the left we have a 0, which we can just swap the sides. We start with the right hand side, then we equate it to what is on the left hand side. Now here what we're going to do is we're going to look for time. So this will be the time taken to reach the highest point. So it will be negative gt equals to negative u sine theta. We'll divide both sides by g, negative g, sorry. Thus we get t to be equal to u sine theta over g. So this is the time taken to reach the highest point. So this is the time taken to reach the highest point. So at that highest point reached, or the highest point the particle will ever go, or wherever is at, on the y direction, that is the time. That's how it is calculated. So you need to keep this formula in mind, as it will be used in one of the calculations that you come across under projectile motions. Now if you remember, the formula for displacement goes like this from the equations of kinematics. And if you remember what we did in the previous video, I stated that acceleration in the y component is equals to 0. Negative g, negative g. That's y will be equals to u, the initial component, minus g, minus half gt squared. Okay, so this would be y there is 2, are going to substitute the formula we found above. So our y, which is the displacement that we're calculating, which is maximum height in this case. So say our y, which is maximum height, will be equal to y there's u subscript y, will put u sine theta, then multiply by t. We're going to replace that, which is u sine theta over g for t. So this is the time for highest point reached. Then you subtract with half, then it's not g, it is half instead, then g, then where this time you put u sine theta over g. Then since this is squared, we're going to square everything that is under parentheses. Okay, so we proceed. So it's y equals to, so you multiply u times u, you get u squared, then sine times sine to give us sine squared theta, then we divide by g, then we say minus. Now if you look at this, outside parentheses we have g, then inside parentheses on the denominator we have g. So the one of the g's will cancel the one inside, but remember that they are squared, so we're just going to bring with 1g down there. So this gives us u squared, then sine squared upon squaring, then over g. Now remember that we're multiplying the 2 outside, so it will be 2g. Then you find the common denominator. So there's a 2g here. Finding common denominator, it is 2g, the same 2g. That's our lowest common multiple. Our 2g, like that. Now g will go into that, we're going to make the 2, then 2 multiply with the numerator that you have here, the first part. So we're going to get 2 u squared sine squared theta upon dividing. Then 2g into 2g just give us what is on top on the numerator, which is u squared sine theta. So now upon simplifying this, we have that they are like them, so 2 subtract 1, so I'm just going to get u squared sine squared, then you divide by 2g. So this is what will give us the maximum height. Thank you very much.